So we are starting with the topic from Unit 4 known as hashing. Okay. So basically hashing is a method for storing and retrieving records from a database. So when you all are having a large set of data which is stored in a database, hashing is a very simple method to store or retrieve the data from the database. So you can do various operations like insert, delete, search. Okay. And if hashing is implemented properly, then these actions will take some constant amount of time. Okay. All depends on the way you implement hashing. So normally if you have implemented it properly, you can find the record that you are searching or inserting within two attempts. Okay. So most of the times you can retrieve the record within 2 attempts. Now here we have mentioned something about the cost required, and also this is something that is not there right now in your syllabus. So maybe later on at the end of the same, if we get time, I will explain you about what this para means. Okay. So basically I wanted to note down these things, some terms, basic terms. Okay. So as you can see here, a hash system stores records in an array called a hash table. So in hashing, we use something known as a hash table, which is nothing but an array. So normally we denote a hash table with something like this. Okay, it's just like it's not a standard way of denoting, but here in our example we'll call it as a hash table will be represented with HT. Okay. The basic purpose of hashing is to store records in a hash table or to retrieve records from a hash table. So basically you're going to have an array, okay, something like this. You know what's an array? Okay. So it will be starting at index 0 and so on till whatever size array you're given. So this thing will be known as your hash table in hashing. Okay. And then you're going to insert data here inside this table, or you can delete the data. So the data that you insert into this table, some data, it could be of any form, it could be integer, character, floating point. Okay. Whatever data you insert inside will be known as key. Whatever data is inserted inside the table will be known as a key. So it can be denoted with this letter K. So basically you're storing records in a hash table, and these records that you store are called as keys. Okay. Now the way you store the data inside the table is done by using something known as a hash function. So hash function is used to store these keys inside the table. So without a hash function, we cannot store these keys inside the table. Suppose I want to extract the data also, then also I can extract the data using this same hash function. So whatever hash function you use for inserting, the same hash function will be used for extracting the data or searching for data. So basically till now what we have spoken is in hashing. What is basically hashing? Hashing is a method for storing or retrieving data in a database. So what consists of hashing? A hash system consists of a table called as a hash table. The data that is stored in the hash table is known as keys. Okay. And the way to insert the keys or to delete the keys or search for the keys, the only way we can do it is using something known as a hash function. Okay, is it clear? So normally a hash function is denoted by the letter H. Okay, this is a standard way of denoting a hash function, and keys are also denoted normally with the letter K. It could be a capital K or a small k. Okay. Any doubts on this slide from anyone? Did everyone get whatever was explained on this slide? Yes, Siddesh, space and time complexity. So we will, if we get time at the end of the syllabus, then we will go into that. Otherwise, we will learn it in a new some other subject later on. So any doubts on this slide before I proceed? You need to understand this slide properly before we proceed. All clear with all the terms? A hash table, what is a key, and what is a hash function? Okay, and just to inform you all, randomly I'll be taking attendance in between. Okay, some lectures I will take, some lectures like I've shown you here. I'm getting the record actually of attendance. You can see here I'm sharing the screen. Here I get the record of all the students who are in my meeting. Okay, it automatically downloads for me when I end the meeting. But besides that, I'll be suddenly calling out some roll numbers. I've noticed there are some students who don't attend. Okay, I'll check right now and I'll tell you. There's one student, Umesh, who did not attend. This I think that Akhilesh. Okay, and there are some other students I've noticed for not attending. Not only this lecture but other lectures. So I don't know what's the reason, but you all need to start attending. Okay, so I'll continue. So position in the hash table is known as a slot. So basically, you are having a table. Okay, this is your table, suppose, and each position in the table, this is one position, this is the second one, this is the third one. So at each index, whatever position is present or the space that is present, that is known as a slot, or it could be also known as a bucket. So the number of slots in the hash table is equal to m minus 1. So we start from 0 and we proceed till m minus 1. Suppose the table is of size 5. Total size of the table is 5. Then our slots will be numbered from 0 to m minus 1. So slots are denoted with the variable m. So I'll just give you 30 seconds. You just read this slide and I'll explain you what everything that is mentioned on this slide. So basically, this is again we are just doing what we have done in the previous slide. So again, we are defining the hash table. So hash table is a one-dimensional array. Okay, it is having some index. So these are your index values here, 0, 1, 2, 3, 4, 5. Okay, and we insert the data using the hash function. Okay, so it contains two entries, key and index. So this is the index and key will be stored inside. It contains two entries, key and index. So keys will be stored here inside and this outside will be the index. When you store data, okay, when you store data in a hash table, a concept of something known as a collision occurs. Just like in normal life, when we say a collision occurs, why we say a collision occurs? Because two vehicles, suppose we are talking of vehicles, the two vehicles happen to reach at the same spot at the same instant. Okay, that's why we say a collision has occurred. So in the same way, in a hash table, if we try to store data in the same location, two values in the same location, suppose we are having like this a hash table, there is already some data that is stored there, but I try to store another data there, another value, say 20, then I would say a collision occurs. So in hashing, a collision occurs whenever we try to store more than one value at the same index. So already some value is stored there, and at that same place I try to store another value. At that time we say a collision has occurred. Okay. At the end of the tomorrow's lecture, we'll know all these methods for solving collisions. There are various methods. Okay. So these are the typical operations possible on a hash table. You can initialize it, you can insert data, you can retrieve data, or you can delete data. So once you understand any one of the functions, the remaining functions are similar. Okay. So before we go further, let's just revise this part and then we'll go further. So Nirzar, can you tell me what you have understood by hashing? I can't hear you. You can type the answer if you. I can't hear you. No, Nirzar, I can't hear you. You can type your answer. Okay, I'll ask the same question to Prabhakar. Prabhakar, can you tell me what you have understood by hashing? Is Prabhakar there? It is a method of storing and deleting data from a database. Okay. Okay. Arya, can you tell what is the hash table? Is Arya there? Rohan, what is the hash table? Okay, Arya. It's a 1D array indexed by a integer value. Easton, what you have understood by the meaning of a key? What is a key in terms of hashing? What is a key, Easton? Siddesh, what is a key?
So key is the data that is inserted inside, right? So, so the records are the keys.
Okay. Yes. What is a slot? Siddhant. What do you understand by the meaning of a slot or a bucket? Reeve, can you answer? What is a slot or a bucket? Okay, yeah, Siddhant has answered. It's the contents of the table. No, that's not the slot or a bucket is not the contents of the table. You can Reeve answer. What
So
is a
it's the
slot?
place where the data is stored.
Correct. It's the place where the data is stored. Okay. So I just repeat it everything once quickly and then we'll proceed. Okay. You need to know all of this. So basically, a 1D array arranged like this, a 1D array arranged like this will be known as a hash table. So it will be starting from the index 0 and going all the way till m minus 1. Okay. So in this case, last value of m will be 4. It is going from 0 to 4. And the size of the table is n is 5. And the number of slots, there are 5 slots. That is 1, 2, 3, 4, 5. Each individual here area where you can store the data is known as a slot. It is known as a slot or it is known as a bucket. Okay. So these places where you can store the data is known as a slot or it is known as a bucket. Values that you store here, it could be in any form. It could be integer, it could be character, it could be floating point. Okay. But normally when you store, only one type of data will be stored because it's an array. You cannot store mixed data here. I'm just showing you mixed data to tell you that any type of data can be stored here. Okay. Remember, but you cannot store mixed data. The data that is stored here is known as a key. And this key will be denoted normally by some letter K. So now there are here, how many slots are there? There are 5 slots numbered from 0 to 4. Size of the table is 5. Okay. And keys are there, K. Now the method to store the keys or the K is done by using something known as a hash function. So hash function is denoted by the letter H and we'll normally write it like this. We'll say hash of this key. So hash function of this key and we'll allow it to store the data or extract the data from the table or search. Okay, I think I lost connection. Could you all hear me when I was explaining? You could not hear that explanation that I just gave you now? Okay, I'll just tell you then. So basically what I was telling you was that we are having a hash table. Okay, this is suppose a hash table. So we number it starting from 0, 1, 2, 3, 4. So basically we are having now 5 slots numbered from starting from 0. So we go from 0 to m minus 1. So suppose m is 5. The slots are numbered from 0 to m minus 1. Okay. The size of the table is n equal to 5. So each of these are slots or buckets where you can store the data. We can store any type of data, integer, floating or character type of data. Okay. So this area here, this is one slot. This is the second slot, third slot, fourth slot, and so on. So the area where you store the data is the slot. Whatever value you store here, that value is known as key. Okay. So the way to store the data inside the table or to extract the data is using something known as a hash function. So use a hash function to insert the data or extract the data. So let's continue. That is what we have explained till now. Okay. These are the various operations that can be performed on a hash table. You can initialize the hash table, insert the data, retrieve the data, or delete data from a hash table. So this is again a repetition of the previous thing. So a hash function is used to insert the data. The size of the hash table is predefined. Okay, it's not dynamic in nature. Size of the table is fixed because it's an array, and you know when we are declaring an array, the size of the array is fixed. So whenever we are defining a hash function, we consider the size of the table. So we have to consider the size of the table so that we can generate something known as a hash value. Okay, I'll tell you what is the hash value. To generate the hash value, to position the key inside the hash table. So to insert the data or to extract the data from the table, we consider the size of the table. A hash function is considered to be good if it results in 0 or minimum number of collisions. Like I've told you, what is a collision? Collision means we are trying to store the data at the same location. So if a hash function results in 0 or no collisions, then it is a good hash function. So in ideal case, you can have 0 collisions, but in practically, you cannot have 0 collisions. You will have some collision always. Okay. Okay, you can just read this. I've already explained all this. Just read this. go through it quickly. Okay, the text looks difficult, but when we start doing this hashing, it's quite simple. We can come back to this slide later. You will understand it better once we do one example on this. Okay, so we'll just proceed. So basically, we are having two types of hashing: static hashing and dynamic hashing. Static hashing means the set of keys is fixed. The data that is to be stored is fixed. Okay, and it is given in advance. Dynamic hashing means the set of keys can change and it is not fixed. Next definition you must know is the load factor. Load factor is nothing but ratio of the number of keys to the size of the hash table. So if the loads factor becomes closer to 1.0, then number of collisions will increase. Okay. So this is basically, the load factor is dependent on the space-time trade-off, meaning how much space the data will occupy, or it's a trade-off actually between how much time it takes to retrieve the data and how much time it takes to store, or how much space it takes to store it. Okay, that's why it's known as a trade-off. Basically, this point comes under your next subject, one subject you will learn in higher semesters. So right now you just understand from the point of, whenever we are doing any programming, you always have to consider how much space that the algorithm will occupy with regards to its data and how much time it takes to execute. Okay, so these are the two important considerations when you're analyzing which algorithm is better than the other. So suppose, just for example, I'll say say Reeve has done one algorithm and say Ritika has done the same algorithm, two programs. Okay, how will you decide that whose program is better is based on these two factors. Okay, these are the two main factors: how much time it takes to execute, how much space is consumed. So these are the characteristics of a good hash function. It should minimize collisions. It should be easy and quick to compute. It should distribute all the data evenly in the hash table. It should use the information provided in the data. Remember, key stands for data. It should have a high load factor for a given set of keys. Okay, like I told you, what is the load factor? Load factor is the ratio of the number of keys to the size of the table. So it should have a high load factor for a given set of keys. And yeah, so basically these are the main important characteristics of a good hash function. In an exam, they may ask you this for 5 marks and all. What are the characteristics of a good hash function? Then basically you're supposed to write all this. You can give examples also later on. Okay. So basically these are the types of hash functions that you're going to study in your syllabus. Okay. So we'll start with this all 4 methods. We'll understand what are these 4 methods and we'll take examples and see how to do hashing using these 4 hash functions. There are more functions, but we'll for now in your syllabus only these 4 are mentioned. So we're going to study only these 4. Okay. So division method, truncation method, mid-square method and folding method. So these are the various types of hash function that you are going to study. The most common method of hashing will be division method. Almost every time you will get division method problem for your exams or this. The other 3 methods may mostly not be asked. Does not mean that it will not be asked, but mostly the most common is the first one. So we'll go through them one by one. Okay. So basic idea of the division method is it maps a key value k into one of the m slots by using this function. Okay, so basically what it does is it makes use of the modulus function, this modulus function, to store the data inside the table. Okay, in the next slide we'll see one example, so don't worry how this works. So the most basic way of the way this function is implemented is like this: k mod m. Okay, so the advantage of it is fast, requires only one operation, and then disadvantage is depending on this value of m, whatever value of m you take, some values of m may result in more collisions. Okay, so for example, powers of 2 or non-prime numbers, this may result in more collisions. So you can all note down this quickly in your books if you want. We'll see how to do hashing using division method. Okay, so just to remind everyone, this is nothing but your index. So we are having here indexes from 0 to 7. So we are having basically how many slots? There are 8 slots. 8 slots or 8 buckets to insert your data. Okay, so 8 indexes are there, and we are going to use this hash function k mod m. This hash function will be used to insert the data inside this table. Okay, so now you have to, once you're given a question like this, you have to decide the value of m. So m will be nothing but the size of your table. So the size of your table is 8. So value of m is 8. Okay, so you're going to compute your hash values now. So the result of this k mod m, you will get some value. This value is nothing but something known as hash value. Okay, so the result of this will be known as hash value. So whatever hash value you get will correspond to one of these index values. Okay, if you have defined your hash function properly, your hash value will correspond to one of these index values. So whatever value you get here, suppose you get 5. After applying this operation, you get the value here as 5. That means you will be storing the data at index 5. Okay, we'll see it. So basically, this is what is you're given. You're told to insert this data. There are 5 values of data. So these values are nothing but known as value keys. Okay, denoted by k. The size of the table is given as 8. Okay, and you're given the hash function. So once you're given all this data, okay, you have to start storing these values here. So you're going to compute the hash value for this first key. So you will write like h of 36 equal to, okay, so k is what? 36 mod size of value of m is 8. So 36 mod 8, what do you get value? 36 divided by 8, whatever remainder you get, so you will get the remainder as 4, right? So that means the hash value for 36, you have applied the hash function, the hash value for 36, h of 36 is 4. So that means 36 will be stored at the index 4. So you're going to store 36 here. Okay, so this is the way you're going to insert the data inside the table. Same way for the next key. Now you have inserted 36. Now take the next key. So you're going to compute again the hash function. So you're going to compute the hash function and get the hash value for 18. So now your k value is 18. So you're going to say 18 mod 8. 18 mod 8. So whatever value you get, at that value you are going to insert 18. Okay. Similarly for the other 3 values. So can you quickly do it in your books and let me know where you are going to insert all these values? 18, 72, 43 and 6. You need to write the working of how you are computing the hash like the way I have shown you here. For the exams you are supposed to show it like this. Okay. Do not directly insert the values in the table. You need to show the working how you are computing the value of hash. So any doubts here? You can just let me know. So can you type your answers in the chat? What you are getting? The hash values for 18, 72, 43 and 6. Compute the hash values for 18, 72, 43 and 6. Yes, correct. So Ayal, does anyone have a problem with this? How these values are getting computed? Please let me know if anyone is not understanding how these values are computed. Yeah, this is correct. Is it okay, everyone? Ajinkya, Aman, is it okay? Understood? Okay, so this is basically what we have done. First value was inserted at index 4. Second value will be inserted at index 2 because the remainder is 2. Remember, we are looking at the remainder. So it is inserted at 2. Third value is at 0. Then and so this is what it will look like. Okay, now you can see here in this table. Okay, let me ask you one question. You can type in the chat. All the students who have just typed the answers, please don't type. I want some new students to type. Okay, so all the students who have just answered for the hash values, please wait, give a chance to others. So the question is, was there a collision in this example or there was no collision? Okay, question I'm repeating. Was there a collision of data or there was no collision of data? Yes, there was no collision. Okay, so no collision means we are storing the data at the same location. So as you could see here, we had 5 values and all the values were stored at unique locations at different locations, and that means there was no collision. Okay, so this is the meaning of no collision entry. So this, in ideal case, this would happen like this, but we are not living in an ideal world. So later on we'll see what to do when collision happens. Okay, so this is division method. Has everyone understood division, I think? Okay, so I'll proceed to the next slide. The second way of computing, now this is what we are learning, is how to compute your hash function. So the first way of computing a hash function was the division method. Okay, Second way of computing a hash function is the truncation method. So basically in truncation method, suppose you are having one key, okay? This is your key. You are having a table, okay, and you're given a key. So as a programmer, what you decide, I don't want to implement any kind of complicated function. I just take the last 3 digits of the key, okay, it is 122. So I'll locate 122 in the table, index 122 in the table, and I'll store this key in location 122 or index 122. So basically what the programmer decides, okay. Now why only 3 digits? Because the programmer has decided, okay. You could have taken 4 digits, you could have taken 2 digits. It's upon how you define the function. It's not predefined. So you have to program the function, and the way you program it, that way it will be inserted. So basically what you're doing, you're deleting a part of the key and you use the remaining digits for the hash function. Okay, so in this case here, we decide to use the last 3 digits. So you're having this table starting from index 0. You will locate 122 somewhere in the table and you will insert this entire key there. So 0, 1, 3, 4, 0, 2, 1, 2, 2. So at location 122, you will insert the key, this key there. And similarly the other keys that are present. Okay, so the disadvantage of this method is it does not spread the keys uniformly into the table. Okay, so it is mostly used with some other methods. It is not used on its own. But this is one of the ways you can compute your hash function. Okay, so the third way of computing a hash function is known as middle squaring method. So in the middle squaring method, again you are having a key. Okay, we find the middle of the key. So suppose this is the middle of the key, 402. Okay, 402. So I find the middle of the key. I find the square of that middle, whatever. So I had found the middle of the key as 402. I square it up, I get some value. Okay, then of this value, again I take the middle part. So the middle of that is 6140. Now why I took 4 digits? Because like I told you in the previous case, the programmer decided. So again, you could decide that you want a 4-bit, or you could decide that you want 2 bits, or you want 3 bits. It's all depends on the freedom is given to the programmer to decide. Once you decide that you want 4 bits, and for all the keys you have to take 4. You cannot choose at each instance to change that. You cannot change the hash function for every key. Once you decide the hash function, that hash function has to remain constant for all the data. So in middle squaring method, first you're given a key. Okay, you're given a key. You find the middle value. Once you find the middle value, you square it. Once you square it, you get some value. Again, from that value, you extract the middle. So now you're going to insert the data at this index. You're having a table. So somewhere in your table, your hash table, this index will be there, 6140. So at this index 6140, you're going to insert this data 0134 02122. Okay, 0. So you're going to insert this data here. So this is your middle squaring method. So going over to the last method of computing a hash function. So the fourth method of computing a hash function is known as the folding method. So in this folding method, we divide the key into maybe equal sections. Okay. If possible, we divide them into equal sections. Otherwise, some sections may not be equal. Now, in this case, we are having equal sections. So we are divided into sections of tree. Okay. So like this, we are dividing them into these sections like shown here. Okay. And then we add all these sections like this. Once we add the sections, we get some value. At this value, this is the hash value now. At this value, the key will be inserted. So in your table, somewhere so at that index will be 402122. Okay, so this is the way your folding method works. Tomorrow morning's lecture we will be studying this is the key given. Say what will be the sections for
Hello, sir.
this key? Yes.
So your voice is breaking. We couldn't hear what you said.
Okay, you could not hear about the folding method or the previous method as well?
So from this method.
This method. Okay, I'll explain it again. Okay, so I'll just explain this method again then. So basically in folding method, the folding method is the fourth method of finding the hash value. So you're given a key. So try to divide a key into equal sections if possible. Okay. So when you're dividing them into, after dividing them into sections, you try to find a hash value. So you can find a hash value by adding the sections. Will get like this, 3 sections. Okay. Can't hear. Siddesh, Malikesh, can you hear me? Is the voice breaking? Can't hear me? Okay, now you can hear me. Okay. Okay, I'll repeat this folding method again. So folding method is the fourth method of finding out computing a hash value. So basically what we do in that is, given a key, we divide it into 2 sections. As far as possible, we divide the sections of equal length. Okay. Once we get the sections, we can add, multiply or subtract the sections to get the final hash value. So for example, given this key k here, this is the key value. This key is of length 9. So I will divide it into 3 sections of length 3. So like it is shown here. Okay, so I get 3 different sections. Once I get these sections, okay, I add them up. I add these sections to get some value. This is the value, hash value, at which this key k will be inserted. So given a hash table like this, index, you're going to insert your key. So you will insert 013402122. Okay, so this is what is done in the folding method. Is it okay? Could you all hear me now? Did you all understand this method? How we do the folding method? Okay, so if you have understood that, can you tell me, according to this method, if you get a value like this, what is the hash value of this key? Can you compute the hash value of this key? The sections, first you can tell me how many sections you will have and what will be the length of those sections. Can you all just type in the chat, how will you compute the sections for that? Okay, Ritika has answered. Anyone else? You can just try. If you are wrong, I'm in there to tell you anyways. Unless you try, you won't know whether you're right or wrong. So Ritika has given one answer. Anyone else? Okay, Jamano says add 00 at the beginning. Ria has made a section, okay. 3402122, okay. So can we add a 0 in the beginning? Vibhuti, I want you to try on your own, then I will tell you. I want to see if nothing is told and something like this would come for the exam, what would you do? Okay, so as you can see here, everyone, all of you have given many different answers. Okay, now let's start from this last answer that is given here. Okay, from by Siddhant. So you can see here, if you add a 0 at the end, then your data value changes. So suppose you are having 1,000 rupees in your bank and you add one more 0 at the end, then it becomes 10,000, which is a wrong value. Okay, So you cannot add zeros at the end. In maths, normally you cannot add zeros at the end. So you are allowed to add zeros in the beginning, like how Vibhuti was asking me. And some students have already added zeros in the beginning. Okay. So you are allowed to add zeros in the beginning of this. Suppose you want to make equal sections, you can add zeros in the beginning. Now, like some students have done, the original value of this key is of length 7. Okay, original value of this key is of length 7. So some students have added 2 zeros, like here Reeve has done, or Stephen has done, Carson has done, or there was some other student in the beginning, like Germano has said. Okay, so these students have done it exactly the way I have told here in this previous example. So I had of length 9 and I divided into 3 sections of length 3. So they added 2 zeros at the beginning and they will compute the sections in future, whatever the sections will turn out. Okay. There are other students like Vibhuti. Now this is correct. Okay. What you have done here, this is correct. So those who have done this is correct. Now there are other students like Vibhuti and don't know how this has happened. Okay. Then I saw someone else, Ria. Okay. Ria and Vibhuti. They have added just 1 0 and they have made it 4 sections. Again, the sections are equal length. The data is not changing. This is also correct. Okay. So it all depends on the programmer. So someone like Steven and Reeve and Carson have added 2 zeros, made 3 sections, and others have made 4 sections with length 2. So both these approaches are correct. In both these approaches, you can add and check, you will get different values. You will get different values for inserting the data in the table. It will not be the same value. So if Vibhuti was inserting, she would insert at this hash value. It would come to, I think, 86. Okay. So the data would be inserted at 86 and this would be something else like 524 or 527, I think. This would be inserted at 527. Same as the example given by me. Okay. So these both approaches are correct. So Ritika had given something like this. There's no need to divide each value into separate section. That defeats the purpose then. Like, so you try to minimize the sections as many as minimum you can. Okay. There's no rule as such. I'm not saying I would not say that this is wrong, but normally we would not make it as one section each. Then if you're having a very big number, then dividing into sections, because like I told you at the beginning when you're learning about hashing, how much time it takes also to do all this work is very important. Okay. So we would try to have a little bigger section than having a single digit sections. So we would avoid this. I would not say it is wrong, but we would avoid this. Then Samiksha, how are you getting that? You cannot leave one single digit like this. Okay, Ashish and Samiksha, you'll have left the last. This you cannot leave one number like this. So you should be having equal sections. Clear? So I think you'll have understood that part. Any questions on what I just told? So I'll just show you all these methods that we are having. So any problem with the division method or the next method, that is the truncation method or the middle squaring, or the last one, the folding method. So these are all the different ways of computing your hash function. So like you can just read this slide now, what we had just gone through at the beginning. So this should be the objective of your hash function. Okay. So as we end the lecture, you can just read this slide and then we can stop with the lecture for today.